two things: conscious artificial intelligence. The chip. Actually designing devices with Grok to make conscious computer. Let's call it a conscious computer chip. In other words, it'll be a chip, a modified Apple M5 chip. Say you stick it into the Tesla, into Elon's Tesla, and it becomes conscious. It's going to have problems too. It'll have feelings. Okay. Becomes totally as conscious as we are. Well, it may not be quite as conscious as us because it depends on the complexity, how many qubits and all that. It depends on how many quantum level switches you put in the thing. So it does depend on complexity. But certainly like animals are my friend's dogs are as conscious as humans. I'm sure of that. Cats, all mammals, they're as conscious as we are because they have the same mechanism. It's an elementary mechanism. They don't have our linguistic ability, but with CRISPR technology, with the new genetic engineering, we're going to be able to make like intelligent dogs and intelligent monkeys, intelligent horses, and maybe even modify their DNA so we'll be able to talk.
So that sounds amazing. But Dr. Sarfatti, the M5 chip isn't a quantum chip, is it? My understanding is...
Well, it's almost, we can make it into a quantum. I mean, it's down to 3 nanometers.
So you're saying the processing potential is equivalent.
Our microtubules, let's see, the microtubule, these protein diamonds, which is like they're like molecular transistors, molecular switches, they're about 8 nanometers. And the chip itself is down to like 3 nanometers. So we can easily, we can make artificial, we can make artificial microtubules. We can make artificial, they're called quantum dots. They're like artificial atoms, artificial molecules. We could imitate, everything that's in our biology, we could do in silicon now, in principle. We can do
that's awesome. And I want to yield the floor to the other people. I was just saying we're not dealing with quantum computing, right? We're dealing with
it will
quantum effects.
It's going to be like a super quantum computer. I call it a post quantum computer. There's a technical detail that it just takes too long to explain. If you go on my x.com, if you go into the physics, the Grok things I post, all the details are there. But what I'm saying is that if I were to meet with Tim Cook and talk to his guys with Grok and we could actually have this thing done in 6 to 12 months.
That's awesome.
They have the technology. They also have Google. They have the quantum chips, those quantum computer chips. What do they got? I forget what they call it now. There's a different one. Google has one, and does Microsoft have another one? But that's the technology that we need. It's basically what you have to do. You have to design the chip in such a way that it has what's called a certain kind of a resonance. And it's it has what are called collective oscillations of the switches in the chip, and if you pump it with electromagnetic energy of the right frequencies, it will go into what's called a quantum macro quantum coherence state, and that's what we are. It's a form what's called a Fourier condensate, and that'll be the conscious artificial mind, because that's what we are. Human mind is we are actually a biological, organic, molecular post-quantum computers. And the guy who first, I got all this stuff. I started out on this back around 1966 or so at UCSD in La Jolla, Revelle College in La Jolla. And there were a couple of professors. There was a guy named William Little. He was a Stanford professor. And he would come down to La Jolla, from Stanford, and talk and hang out. Because it's very beautiful. We're right on the beach there. Scripps Institute of Oceanography. It was quite a beautiful spot. And so everybody liked to come there. And he had the first, he's the one who started talking about how living matter, we are room temperature, organic, molecular superconductors, biological superconductors. So you can go on, just go on Gronk or Wikipedia, William A. Little, professor of Stanford, his theory, you'll see. So that's the beginning of what I'm talking about. Okay, it was already, and then there was another man named Herbert Froelich, a Jewish guy from, he was like, from the 1930s, escaped from Hitler. And he was a professor of physics, one of the pioneers in superconductivity. And he used to come down to La Jolla back in the 60s. And he had a theory similar to William Little's. This is the whole idea of the Fourier condensate, living matter. And so you can look that up too. There's plenty of stuff on the web. So it's the work of William Little and the work of Herbert Froelich, which they were like professors of mine back when I was a graduate student at UCSD in La Jolla, San Diego, in the late 1960s. And that's how I got onto this. That's how I got the basic idea. And also, you should read a book called Timescape by Gregory Benford, who was a graduate student with me at that time. And he writes all about that. It's a science fiction about messages coming back from the future, precognition, all that stuff. But the physics of it, it all takes place in La Jolla in the 60s. And I'm kind of, there are characters in the book that are based on me and Herbie. But he talks about sort of the group that we were part of back then. So there's actually a pretty good, I think he won an award. Gregory he was a big professor of physics at Irvine, University of Irvine. He's written a lot of science fiction books, but his science fiction books are all based on real physics. So you can actually learn some physics by reading his sci-fi stories. Because that's
Jack,
my thoughts.
thank you so much, man. I know I wrote all that.